So we are going to talk about lesson 6-5, and if you're in the Algebra I textbook, you're on page 229. And our objective with this lesson is to be able to solve quadratic equations in which the left member is a trinomial square. So in order to do this lesson, we need to jump back to lesson 5-9. And that's going to help us remember what a trinomial square is. If we have, for example, x minus 5 squared, we know that it's going to be x squared is going to be our first term. We know that our last term is going to be negative 5 squared, which is positive 25. And we know that our middle term is going to be the product of these two terms here, so negative 5 times x, which is negative 5x, and we're going to double that and get negative 10x. This answer here, this x squared minus 10x plus 25, that's called the trinomial square. So, suppose we are given a trinomial square, such as, and let me review one quickly from lesson 5-9, which you can easily look back at in your textbook. Suppose I have x squared plus 12x plus 36. The question is this a trinomial square? And the answer is yes. It is a trinomial square because I can write x plus here, the square root of 36, which is 6. And I know that this works because 2 times 6 gives me that 12. Okay? Let's do one where it's not a trinomial square. X squared plus 10x plus 64. So, if we look at this one, again, we're going to put our parentheses up, and we're going to take the square root of that 64, which we know is 8, and we're going to take the square root of x squared, which we know is x. But is 2 times 8 equal to 10? Obviously not. And I'm getting that 10 from that coefficient of the middle term. So this is not a trinomial square. And again, the answers, or the examples I should say, in lesson 5-9 are really good. So I'd recommend, if you're still having trouble with this, to go back to lesson 5-9 and look at it. Now let's jump ahead to lesson 6-5. How are we going to use the trinomial square in this lesson? Well, let's look at an example, okay? Suppose we have x squared minus 10x plus 25 equals 70. How will I solve this? Well, the first thing we need to know is this a trinomial square? And let's look at that. Well, I know the square root of 25 is 5, and I know that 2 times the square root of 25 gives me 10. Okay? So I'm going to say x minus 5 squared equals 70. So this is indeed a trinomial square. Now it's in the form of lesson 6-4, what we learned in lesson 6-4. So at this point, we can then take the square root of x minus 5 squared and say that that equals the square root of 70. Okay? At this point, we learned in lesson 6-4, when we take the square root of this, we're going to get the absolute value of just that binomial, x minus 5, equals, and it will be plus or minus the square root of 70. Then, this is now in the form of lesson 6-3, and we know how to solve this because we're going to create basically two expressions here, right? we're going to say x minus 5 equals the negative square root of 70, and x minus 5 equals the positive square root of 70. We can solve these out to say that x will equal a negative square root of 70 plus 5, and x will equal the positive square root of 70 plus 5. At this point, I'm more than happy to let you use your calculator to solve these out. And when you do this, you will get a solution set. I'll put the answer up here. A solution set of 13 and 37 hundredths and negative 3 and 37 hundredths. Okay? So the idea here with lesson 6.5 is if you're given an equation, the left member of it is a trinomial square, then you can factor that trinomial square to get into this form of a binomial squared, basically. Okay, it looks like a binomial raised to the second power. Then you can take the square root of that and go on just like we have been solving our equations from lesson 6.4. I'll go ahead and do one more example for you. Let's look at, and this is example 1 on page 230 in your textbook. If we have a problem and it says x squared plus 6x, oops, I should not write on the slant, plus 6x plus 9 equals 113, okay? First question, is this a trinomial square? Well, let's think about it. Square root of 9 is 3, and is 2 times the square root of 9 6? Yes, because 2 times 3 is 6. So this is a trinomial square, okay? So I'm going to do x plus 3 squared equals 113. Now it's in a form that I can solve. I will take the square root. X plus 3 squared equals the square root of 113. This will give me the absolute value of x plus 3 plus 3 equals the square root of 113. Then I can say x plus 3 is going to equal plus or minus the square root of 113. When I solve this, I know that x is going to be equal to plus or minus the square root of 113 minus 3. I've just moved that 3 over to the side, okay? That's how I get the minus 3. At this point, I can solve it to get the solution set, and I can use my calculator if I'd like to do this. And my solution set will be 7 and 63 hundredths and negative 13 and 63 hundredths.